Okay, we're looking at systems of inequalities, linear inequalities, section 8-7. Definition: systems of linear inequalities are two or more inequalities in the same variable. Basically, you're going to graph two linear inequalities, so just like we were doing. Now we're going to just graph two of them, and then we're going to determine their intersection. So a solution might look like this, where we have this line graphed here, and we have this one graphed here. We did our shading, and we're looking at where the double shaded region is. So in other words, the solution set over here. So any point in this area would be a solution for this line, and it would also be a solution for this line. So if we tested it, it would be true for this one and for this one. So let's start with this one. We have y is greater than negative 1/5 x plus 2. So we just start at 2. Oops. Start at 2. We're going to go down 1 over 5. Or up 1, back 5. So that we have a negative slope. It should be dashed because there's no underline. And then we're going to shade above. Now, I'm going to show you a shortcut. Okay, we've been testing a point. But let me tell you, if it's in slope-intercept form, there's a little way we can kind of cheat, okay? If it's in slope-intercept form, this says it's greater than the line. That means it's going to be above the line. If it's less than, it's going to be below the line. This only works in slope-intercept form, okay? So for this pink one, let's try that one. Y is less than or equal to x. So we'd start at the origin, go up 1 over 1. Okay, down 1, back 1, blah, blah, blah. All right, we have this one's a solid line. And if we use the shortcut, it's everything that's less than that line. So it's going to be everything on this side, below the line. And then we're looking for that double shaded region. So the double shaded region is going to be this area right there. And that's our solution. All right, let's try another one. So this one starts at negative 3. And then I'm going to go up 4 over 1. Let's do one more. And that's going to be solid. Okay, and because it's greater than our line, that's everything on this side. And this one is a vertical line at 1, dashed. And we want everything greater than 1. So that's going to be everything this way. Okay, so my double shaded region is actually just this little part right in here, where it's to the left of this line and to the right of that line. It would just be that little sliver right there. Okay, another one? All right, now this one, again, if you choose method B or method 2, that's the cover up, right? So 3 times what gets me 12? That'd be 4. And my y-intercept, negative 2 times what gets me 12? That'd be negative 6. That's great for drawing the line, but we can't do the little cheating, the little shortcut. So you'll have to test a point if you do method 2. All right, so I'd have to test, let's say, the origin, okay? So 3 times 0 minus 2 times 0, is it less than or equal to 12? 3 times 0 is 0, 2 times 0 is 0, 0 minus 0 is 0. So is 0 less than or equal to 12? Yes. So I'm going to shade this side. All right, let's try method 1 on this one. So that's where I'm just going to rewrite it in slope-intercept form, like we've been practicing. So it starts at negative 8. And we're going to go down 4, right 1, or up 4, back 1. And this one would be solid. And because it's in this form, we can do the shortcut. So if it's greater than the line, that's everything above the line. So that's everything on this side of that line. So our double shaded region would be that part right there. Okay, so I showed you 2 different methods. Here would be using method 2, graphing it with the x and y intercepts, and then testing a point for the shading. Or you can put it in slope-intercept form, and then you can use the shortcut to decide above or below for the shading. They both kind of take about the same amount of time, so it's really just a matter of which one you like. I'm going to tell you as a math teacher, I would prefer you do this method, because you need to be really good at solving equations for y. All right, so let's do method 1. We subtract 3x, start at 6, and down 3, write 1. Solid. Sorry, I can't see with the shadow. And it would be shaded above. And my other one, let's see, so I subtract 3x, divide everything by -1. Because I divided by a negative, I got to flip my sign. So it starts at -6. And I'm going to go up 3/1. And this one would be dashed. Okay. And we want everything above the line. So that's everything on that side of the pink line. And our double shaded region right in there. Okay. All right, let's do method 2 just for fun. X-intercept would be 8. Y-intercept would be 8. And dotted. If I test the origin, it's false, so that means I shade the other side. Okay, this one is already in slope-intercept form, so let's just graph it. We start at 10. We go down 1/1. Okay, dashed. And shaded below. So our double shaded region, looks like we have 2 parallel lines. Our double shaded region would be right there in between those 2 lines. All right, last one. We're going to do all 4 of these on the same graph, and then we're going to see what shape we get. So we'll start with this one. Starts at -5. And we're going to go up 2/1. And dashed. Now this will actually work better with a pencil. Just kind of shade it lightly. But right now I don't really have a choice here, so I'm going to go like this. But with your pencil, just shade lightly, and then when we get the shaded region for all of them, then we'll make it a little darker. All right, let's try this one. Starts at -5 again, but this time we're going a negative slope. And dashed. And greater than. Okay, so far we have this V going up the middle there. We got gray. Okay, so X-intercept is 2.5. Y-intercept is -2.5. And if we test the origin, it's false. So first I gotta draw my line here. Is that right? Doesn't seem right. Let me solve that. Hang on. Y is less than -2.5 plus X. I guess that's right. Okay. So we want everything below that line. Okay. And one last one, the blue one here. X-intercept would be -2.5. Y-intercept would be -2.5. Dashed. And we would want, let's see, if we test the origin, it would be false, so we're going to shade below that line. Okay, like I said, hopefully you used a pencil on that. It'd be a lot easier to see. But basically, we end up that right there, which is supposed to be a kite. Okay, so we ended up with a kite there in the quadruple shaded region.